Okay, that does it for metal systems. Any questions? No? Okay, good. Let's move on to chlorinated polyvinyl chloride, more commonly referred to as CPVC. As you all know, CPVC is a specially formulated high-temperature thermoplastic which is currently being used in everything from plumbing to fire sprinkler systems to industrial applications. And the facts indicate it's enjoying great success. It's gaining universal acceptance, and its use continues to grow. Now, because of its success in the marketplace, we're going to take a look at a CPVC compound developed by Novion for use in fire sprinkler systems. BlazeMaster CPVC pipe is manufactured to exceed ASTM standards. The pipe and fittings are made by a select group of quality manufacturers and are known by the trademark BlazeMaster. The NFPA Sprinkler Systems Handbook mentions Novion's piping prominently in those sections dealing with CPVC systems, recognizing its listing and expanded usage. In fact, BlazeMaster fire sprinkler systems are listed for use in more applications than any other non-metallic system. BlazeMaster has been listed for use in light hazard and residential applications in accordance with NFPA 13, 13R, and 13D. And it's the choice for historic buildings such as University of Notre Dame, the Governor's Mansion in Virginia, and Madame Tussauds Wax Museum in London. It's also listed for use in air plenum spaces, but we'll talk more about that later, okay? Now, in order to obtain these listings, a BlazeMaster fire sprinkler system was subjected to a battery of different tests by underwriters' laboratories. These tests included physical and mechanical properties, pressure and fire exposure tests. Now, before we take a look at some footage, I should say that rigorous tests were conducted to assure the fire prevention industry that CPVC sprinkler systems would perform as intended when installed in accordance with its listing and the manufacturer's installation instructions. The purpose of these tests was to determine the pipe's ability to withstand extreme direct fire exposure conditions for periods of 10 to 30 minutes and still deliver water to the heads. Finally, the tests were conducted in a very large room, which of course slows sprinkler head response time, and this really puts the system to the test. All right, let's take a look at some footage. Now, in this first test, light hazard extended coverage sidewall sprinklers were installed on 18-foot centers with the sprinkler deflectors 6 inches below the ceiling and within 4 inches of the sidewall. A 5-square-foot pan of heptane was ignited under the sprinkler assembly. Peak temperatures for this test exceeded 1,000 degrees Fahrenheit. At about 23 seconds into the test, the first head activated, having little or no effect on the fire due to the nature of heptane. The sprinkler assembly was subjected to these temperatures for 10 minutes, the test duration, then examined. Now, at the end of the test, the pipe was examined, and it's apparent that no damage had occurred, aside from the slight charring of the pipe's outside surface. A system integrity test was then conducted in which the system was pressurized to 175 psi for 5 minutes. This confirmed that no damage had occurred to the material. Now, in this next test, BlazeMaster pipe and fittings were evaluated for use in unfinished basements with exposed solid wood joists. In accordance with NFPA 13D, the sprinklers were installed on 12-foot spacing with the sprinkler deflectors 1 3/4 inches below the bottom of the solid wood joists. Now, this was done in anticipation of a future installation of a finished ceiling. Again, heptane was ignited under the sprinkler assembly and burned for 10 minutes. Next, a very severe test evaluated BlazeMaster pipe and fittings for use as vertical risers in unfinished basements with exposed solid wood joists. Now, in this case, the vertical pipe was placed only inches above the heptane-filled pan. At about 10 seconds into the test, the first head activated. As in the previous test, after 10 minutes, the system was examined and passed with the same impressive results as all previous tests. The BlazeMaster pipe was also tested dry in a Steiner tunnel to determine its suitability for use in air plenum spaces. The bottom line is that it far exceeds both optical smoke density and flame travel requirements as defined by NFPA 90A. The determination was that BlazeMaster pipe and fittings are perfectly safe for use in plenum spaces in accordance with NFPA 90A. In order to retain the UL listing, Novion and their team of manufacturers has to submit to follow-up tests. Now, these are conducted unannounced on random samples taken directly from the manufacturer's plan. The material is subjected to physical properties tests such as vice crush, drop impact, and a quick burst test to ensure that the materials meet the same quality standards as they did during the initial testing. In addition to these UL tests, Novion has a quality assurance program that regularly samples BlazeMaster pipe from the field to ensure it meets strict quality standards. All right, let's take a few minutes here to address some issues that have been raised concerning CPVC sprinkler systems. First, you all know about the burn characteristics of plastics. If you apply a flame, they either burn and give off smoke and gases, or they char. Well, CPVC chars. The charring acts as an intumescent barrier for protecting the pipe from further damage. This same physical property also means that CPVC cannot propagate or sustain a fire. In other words, as you've just seen, CPVC also has an extremely high limiting oxygen index of 60 and will not support combustion. Most building materials in use today have LOIs of 21 or under, making them quite flammable. And because of its high LOI, CPVC can never be the source of ignition for a fire. In addition, as we saw in the UL tests, it doesn't participate in flashover, which may occur at temperatures as low as 900 degrees Fahrenheit. Now, I know a lot of firefighters have questioned whether or not CPVC is toxic under fire conditions. Let me just say two things. First, according to the state of New York, CPVC is less toxic than Douglas fir, or just about any other building material in use today. And second, we're talking about a fire containment system. The fact is that this system is so effective, it will actually help control emissions of all kinds by controlling the fire. All right, we're going to move ahead now and talk for a moment about some design-related issues. Because of its physical characteristics, CPVC will expand and contract with extreme changes in ambient temperature. For that reason, expansion and contraction considerations should be incorporated into the designer's blueprints, especially when a long straight run of pipe is to be installed. Now, another question that comes up frequently is the transition between CPVC and metal systems. This may occur, for instance, at the junction between the sprinkler system and the main water lines into the building. Let me just say there is a wide variety of fittings available for transitioning between CPVC and other materials such as steel and copper. Finally, let's talk for a minute about fire stops. Whenever a contractor penetrates a fire-rated wall with fire sprinkler pipe, he has to restore the wall to its original rating. UL has tested CPVC with numerous systems and has found that they can achieve a 2-hour rating. BlazeMaster Caulk and Walk is one of the UL-listed fire-stopping materials that has been tested to ensure compatibility with BlazeMaster pipe and fittings. Now, when you take all this into consideration and add to it the fact that BlazeMaster pipe and fittings install quickly, easily, and efficiently, seems like a logical choice for light hazard and residential applications. Okay, any questions? Yeah, Kevin.